says lesson 8.4, rate of change. The rate of change is a rate that describes how one quantity changes in relation to another quantity. For example, the table below shows Stephanie's heights at ages 9 and 12. The change in Stephanie's height from age 9 to age 12 is, well, her height went from 53 to 59 inches, so the difference between those is 6 inches. 59 minus 53 is 6 inches. This change took place over, well, from age 9 to age 12 is 3 years. 12 minus 9, 3 years. Now, if you remember back in Chapter 7, we talked about unit rates. As a unit rate, nope, that was Chapter 6. Sorry, Chapter 6, we talked about unit rates. As a unit rate, we want this to be some amount per year, some number of inches per year. So 6 divided by 3, that's 2 inches per year. So that is the rate of change shown in this table. She grew at a rate of 2 inches per year. And that's basically what we're doing in this section. It's finding the rate that something is changing. Hence the name rate of change. So, example 1, the graph shows Joseph's quiz scores for the first 5 weeks after he joined a study group. Find the rate of change from week 2 to week 5. So we're looking at week 2 to week 5. Okay, so the change in his quiz score goes from 76 to 89. So we want 89 minus 76, and that is 13. Well, this change took place over 3 weeks. 5 minus 2, 3 weeks. So to get the actual rate, we want 13 divided by 3, and that comes out to about 4.3 points per week. Okay. So the first try it yourself problem, you're going to do the same thing. You're going to use the same graph, but now you want to find the rate of change from week 1 to week 3. So do the same thing, figure out what the rate of change was from week 1 to week 3. So pause the video, work through those problems, and when you're ready to continue, press play to check your answer. Okay, from week 1 to week 3, you should have gotten a change of 4 points per week. Okay, example 2. The table shows the distance that Amy travels during a week. Find the rate of change. So now we're finding the rate of change from the table. So if we look at the change in distance, the distance went from 174 to 406. So the difference between those will give us the amount of the change. And then the change in the time is 7 days minus 3 days. And 406 minus 174 is 232. 7 minus 3 is 4. 232 divided by 4 is 58 miles per day. Okay. The try it yourself problem on the back of this page is similar. You have a table and you're trying to find the rate of change. So pause the video and work through try it yourself 2A. When you're ready to check your answer, go ahead and hit play to compare your answer to mine. Okay, and the rate of change for this table, we should have gotten 96 steps per minute. Okay, rates of change can be positive, negative, or 0. So far we've only seen ones that are positive, but it is possible, if something is not changing at all, it's possible for a rate of change to be 0, or if something is decreasing, it's possible for the rate of change to be negative. And we'll see that in example 3. Example 3 says, Natalie is selling cookies. The table below shows the relationship between the hours spent selling and the number of cookies that remain. Find the rate of change, interpret its meaning. Okay, and this is the first one we've seen where we've had more than just two values in the table. The tables that you'll see will have, for now anyway, should have the same rate of change. So here, the rate of change from 0 hours to 3 hours should be the same as the rate of change from 3 hours to 5 hours. So it doesn't matter which two of these three rows in the table we use. So let's go ahead and use just the first two. So from here, the amount of cookies are going from 100 to 40. So to find the change, we want 40 minus 100. And then the hours are going from 0 to 3. So to find the change, we'll do 3 minus 0. 40 minus 100 is negative 60. 3 minus 0 is 3. And negative 60 divided by 3 is negative 20. This means that Natalie sells 20 cookies per hour. Because the number of cookies is decreasing by 20 per hour. So she's selling 20 cookies per hour. Okay. For the try it yourself problem, you're going to do the same thing. You want to find the rate of change in Lauren's savings account after X weeks. So go ahead and pause the video, work through that example, and when you're ready to check your answer, go ahead and hit play. Okay. For this one, you should have also gotten a rate of change of negative 20. And the interpretation of this means that Lauren spends $20 per week. Because the amount in her savings account is decreasing, that means she's spending money. Okay. And the last example, example 4, says the table shows the yearly income of two families. Compare the rates of change. Okay, so here we have the time in years, and we can see what's going on with the Miller family's income and with the King family's income. So we want to compare these two rates of change. So let's look at each family one at a time. For the Miller family, let's find their rate of change. And let's just look at the first two, since we can see that this is a constant change each year. 49, 50, 51, 52. So let's see what we get from the first 2 years. So from 2004 to 2005, their income goes from $49,000 to $50,000. So we'll do 50,000 minus 49,000. And the year goes from 2004 to 2005. So we'll do 2005 minus 2004. 50,000 minus 49,000 is 1,000. And 2005 minus 2004 is 1. So this is $1,000 per year. And we can see that their income is increasing at a rate of $1,000 per year. And given that, you can probably figure out what our result is going to be for the King family, but let's go ahead and see what this looks like. So for these 2 years, the change is 52,000 minus 50,000. And then the change in years is 2005 minus 2004. And when we subtract these, we get 2,000. When we subtract these, we get 1. So that is $2,000 per year. So to compare these, we would say that the King's income is increasing at a higher rate. Because their income is increasing at a rate of $2,000 per year, and the Miller family's income is only increasing at a rate of $1,000 per year. the king's income is increasing at a higher rate. So when you have two, and we could do this from a table or from a graph, either one, when you have two different sets of values, you can compare the rate of change in each one just by looking. In this case, we looked at two of the same same time spans from 2004 to 2005, and that will allow us to see which one is increasing faster or slower than the other one.